Hey everybody! Alright. Let's see. Alright, so episode 3 is live. Let's see. Meta. Okay, just posted that. Okay, so that's live. You just go to discourse. See how many views I've had. I've had 22 views. Okay, so maybe another one. Speak view. I should edit. I should reply. Okay, so okay. Let's see how this goes. Okay, right. So the sound works. Yeah. Let's quickly see here. What was my complaint here? Okay. I just want to say to the person who makes Elm tooling, brother or sister, you're amazing, and I really love the fact that the tool exists. So please ignore my complaints about Elm tooling. It's given all the other benefits that I get out of the Elm community for free. I must say, nothing but love, everybody. Nothing but love. Okie dokie. So let's quickly think here. Yeah. So, okay, first things first, I gotta close everything that is unrelated to coding, otherwise my ADD gets the better of me. Alright, so I've basically got to set up my goal file, so I actually know what I'm busy with, otherwise my brain don't work. Alright, so for now, what I think we're going to do is we are going to do gravity. Which actually, hold on. Yeah, so we are going to further improve the files a bit, and I think we need to do gravity. And then I think as a bonus, we should do better ship graphics. Yeah, so bonus. Okay. So, for everybody who's new here, we're building a Space Pew Pew game, which is a clone of the old Star Control 2 game, which was flippin' wonderful when I was 12. It's still actually a pretty sweet game. There's not like really like a mass version of it at the moment. So, yeah, so I think it's kind of novel. It's also cool because it's the kind of thing that can live entirely maintained inside of a browser. Yeah, and it's the kind of thing that can basically it's the kind of thing that can also, like, I think it'll work well on Lamdera, and it'll also like show lots of Lamdera's really cool properties. Okay, so first things first, we want to continue to make the files a little bit better. I just want to show you guys a anti-pattern that I just saw that I didn't quite like. So typically in most languages, like once you start seeing anti-patterns, you know, people, many years ago there was a book about extreme programming, and one of the principles was refactor mercilessly. The problem with refactoring mercilessly in most platforms, however, is that it's really kind of difficult to actually refactor properly without tests. If you're going to have to re-architect large parts of your system, then your tests are going to be brittle. You know, and you sort of like spin your wheels a lot. So I definitely don't subscribe to refactor mercilessly. But having said that, I just want to show you guys some stuff here, right? So one of the things that I just want to show this, for instance, right? So here we have here I'm just rotating the ship, right? So basically we have an update game function which we could move somewhere better than necessarily the front-end.elm file, you know, but yeah, we have a rotate ship thing, and what we basically do is we just find the first ship, we rotate that, and then we give the list of ships back there. But you'll see this happens, right? So we have like old state here, right? And all we really wanted to do was we actually just wanted that to be there and that to not be there. That's really all we wanted to do. And sort of a similar thing here. We kind of also didn't really want to do that, right? We actually kind of wanted to do something to that effect, you know. So that's kind of like more what we wanted to accomplish. You know, might just say something and not have that. Now this is not valid Elm, so please ignore this completely. But I mean, anyway. So yeah, so I see this kind of thing happen like quite frequently, where I have to sort of like get the old value. And I mean, if any of you GigaBrains have a better suggestion for me there, I'm completely open to hear it. I would love to know how to do this better. Yeah, so my thinking here is trying to think through this properly now. I'm just wondering whether or not I should rename physics to game state, then have or to game or something, and then basically have this update function rather do that. At the moment, basically, we have a game message, we get a model, we return another model and another command there. So I guess one of the first things that I can do is just quickly check where I call this. So I call this basically there. I'll actually give it the model. Because what I could do is I could actually say game state. Game state. Alright, so now at least I think I'm going to be able to remove lots of this stuff. Yeah, there we go. So now the AI should be picking up what I'm putting down. Yeah, there we go. Good, get in there. Okay. Pick that up the wrong way. That's better. By the way, do yourself a favor and never buy a cheap Bluetooth 4 dongle because you think all Bluetooth is the same. It is not the same. Here, old name state. So what's this bitching about? Okay. 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 Well, I haven't had any viewers yet, but I did gain, I think, 3 whole subscribers. So that's good. That's something. Move here. Name state. It reminds me, I need to send people some messages while I think of this stuff. So give this over there. See if that's working. All right, we got rotation. Okay, awesome. Okay, so essentially what I just did was I just cleaned this up a little bit. To see if frame ticket is necessary. Okay. Outline here quickly. Okay, so that's definitely one part we can strip out, which is the render part. So to call that render SVG, since what I want to do later on is actually render lots of this stuff in different ways. Okay, so render projectile.
It's 1930.
Let's quickly have a look here. Render ships, render planet, render game. Oops, functions. Okay, so let's grab that. Let's chuck it in here. So import SVG attributes. Let's import types. Let's import HTML. SVG. Okay. Here quickly. Okay, so this is going to complain because it doesn't know how to render this. So it's pretty straightforward. Okay, cool. So you see one of the cool things is that. So now let's just say SVG expressive game. See where I'm using this. I realize I'm not super talkative in each of these streams necessarily. Okay, so I have update game. Just trying to think now if I ever actually need another, if I ever actually have something coming back. It's a game message. We might later on, when we actually have the game running on the back end. Trying to think if it's at all relevant now. Let's see here, where do we run this? So we run this. I'm just going to leave the update game in here for the time being. It'll come to me if there's a better way of doing it, I guess. Let's have a look here. So physics. Right, so I wanted to add some stuff to physics, basically. I went for a walk in the forest and many thoughts hit me. So one of the thoughts that hit me was basically that I'm going to apply a force to something. And applying a force to a thing isn't always going to be a rocket. So I was wondering if I got a rocket, got a body. Okay, so mass, position, velocity, and radius is what a body has. So if I go body, is this still going to work? Yeah, that was the other thing. Vectors. I need better vector math. So I was going to say, make some vector functions which will be used here. This is definitely overkill, so we don't want to do that. So make only the vector functions that we use here. Okay, so we have, when the heck we use scale vector? We didn't use scale vector, do we? Vector from angle, so we have the magnitude and we have the angle, so that makes sense. Scale vector? Oh yeah, we do use scale vector because we calculate the moment. Okay, cool, that makes sense. Add vectors, yeah, so we definitely use that. So here we both add and scale. I wonder if we wrap vector. Let's have a look at their wrap coordinates. So we're going to circle back and fix this in a moment. So what I'm doing at the moment is I am trying to actually apply forces. Yeah, so I'm trying to apply forces instead of having the thrust calculator. So the way that it works as it is at the moment is that I have a rocket type that is a body, but a rocket has rotation additional to everything else that body has, and it also has a certain amount of thrust, that's expressed in force. But when I was walking in the forest, I thought about it. And since I'm going to need gravity, we're going to need collisions, we're going to need all manner of other things that are basically forces, we would rather need to be able to apply forces. So that's kind of like what I'm thinking at the moment. Yeah, is that I want a more generic force type of thing. I want better vector math. Yeah, so this add vectors and this kind of stuff is kind of like not very, very terse. So I'm just going to rename this as well to like add v. Let's make that scale v. Let's just say from angle. Yeah, I guess wrap v to space is fine. So we'll just say k. Make nicer. Make nicer. So that's correct. Right, so now we have move. And if we have move, we basically say add vector, wrap vector to space. Let's just say there. Okay, so we get that. We basically do a scale vector for the moment. That's all right, I guess. Better. So let's see if this makes sense. So acceleration vector. So we get that from the angle. That's not better. Project. Should you use vector math rather? if we still use this anywhere. I really use it inside of that, so I guess I could do this. Just put it in there. Rotate. Now, another thing I want to improve is I want to improve the rotational speed of each of these things. So let's see what I can do about that. Although I don't think I'm going to do it right now. Scale. HTML things. Physics. Right, so accelerate. We actually want to change it differently here. We want to so I'm just going to use this temporarily. Well, what I typically do is if I have like some sort of object, I kind of do that. Rocket, thrust. Just so, well, it's sort of like semi-object oriented type behavior, I guess. Collisions. Collisions are generic bodies. What I want to do is I want to say life force. There we go. That's what I want to do. Thank you, computer. Thank you, clever. Sonnet 3.5, baby. Okay, so new velocity. Velocity. That doesn't sound correct. No, that is not correct. Just look through this. So mass times acceleration, therefore acceleration equals that, which makes sense. There, okay, cool. So that makes sense. So I'm gonna go. That's cool. So I'm going to apply force. Move the body in space. That makes a form of sense. So if we apply force, that's cool. Look at thrust. So comes up with. Acceleration from thrust. Rocket.thrust. So the thrust is definitely the force. I'd rather say rocket velocity. Angle, it gives us magnitude angle, apply force will take the body's mass. Okay, yeah, that makes sense. I can take that out. Let's see where this is used. Not used anywhere anymore. Rocket thrust. Let's see where we use that. So we use that over there. Okay, so let's see what. Does this still work? Yeah, baby. Elm and Sonnet for the win. Honestly, like strictly typed languages and LLMs are a match made on the internet, I guess. So, oh, that's beautiful. Such a thing of beauty. Alright, so apply force. So rocket thrust. Alright, so we can. Okay, right. So if we apply a force, we have the force which we apply to a body. That makes sense. So if you're used to like object-oriented programming, like typically in object-oriented programming, if you know how the virtual table, the VLOOKUP table works basically, the thing is essentially that the first implied parameter is actually just the record. And if you call the, like a method on an object, it just by implication passes a, like a reference to the object in there. In functional programming, sort of works semi in reverse. Like you get a new version of your record out, and the last thing that you typically pass in, instead of the first thing, is the record that you were working with. And what that just allows you to do is it just allows you to do cool stuff like this, where you basically like, add vector is just essentially like we get a vector there and we add it to the previous vector. Right, and then we get a vector out, but then we want to scale that, we want to wrap that vector inside of our space, so we just apply that vector to wrap vector space. So that's sort of a way to think about it. But the best is to, fork this project, play with it, go do cool stuff, get the idea. Alrighty-o. Okay, cool. So, which of my goals have I hit? Improve the file structure, did I? Improved it a bit, I guess. Took an axe to this thing. That's good. That's always good. When you code, there's something there already. You want to see sometimes, like at a certain point in the development, you want to see less code. Oh, like so much less code. Look at that. That's what you want to see. Delete, delete, delete. That's what you want to see. Alrighty-o. Okay, so how much more should we improve this thing? Do you guys think? We have physics. So we have add v, scale v from angle. So do we make that angle 2v? What do you guys think? hold on a second. I must press pause.
No. See it, just see it.
Okay. All right. So, I love this. This is so cool. That's another thing I want to add. I want to add rotation speed, baby. What do we do here? Look at how smart this thing is. So cool. It can even see that I want to take that out. I love it. Love it. Thing. Oh yeah, I don't want to call it thing anymore. If it's a rocket, I want to call it a rocket. So let's see. Yeah. Thing. Yeah. No more things. Bodies. We have rockets. No, we don't even have degrees to radians anymore, but I think that's going to come in useful later on. Might or it might not. Okay, let's just leave it there for now. Transfer momentum, chip collisions, rocket thrust, life force. So this front end thing is going to break because first chip needs rotation speed, baby. Rotation speed, baby. What else did we change, by the way? If you want to know what you did wrong, you can just go look there. So rotation speed, you might not have saved something. Ship. We didn't update ship. This is not functional programming, people. That is an inheritance. We have to add rotation speed there manually, like barbarians. So look. Alright, so there's obviously like a certain rotation speed. We get a sort of an idea there. Let's go back here. So our rotation speed for ship 1, let's make that 5 times faster. See what happens. Whoa, nearly. Yeah, no, that bad boy rotates now. She rotate bad. By the way, this is another problem that I noticed. Like the faster you can tap, which means that the thing will be very, very gameable. Okay, let's move this bad boy down. Okay, cool, that's done. Just want to see if anybody's actually interested in my... No one cares. He loves me. Why? Because it's only my third video, that's why. Okay. Pew pew pew. Okay, so check our calls quickly. So we further improved the files, I guess. We haven't implemented gravity. We have 2 minutes and 20 seconds before I have to pause again. So further improve the files. We get there. I think we did. Gravity, we haven't got there.
It's 20 hours.
Because we now have apply force, we can actually like calculate the gravity. How flippin' cool is that? Because gravity is just another force. So what we can say is we can just basically say gravitational pull 20 bodies. Let's have a look at what it came up with. So, you know, and the hell do we use angle to vector? Oh yeah, because it needs to calculate the angle. That distance bit is correct. Say angle between those two bodies. Yeah, get the angle. Oh man, where am I going to go? Gravitational force. Okay, so we got the gravitational force there. Joshu. Center of mass. Gotta make that list of bodies. Listen, freaking love this stuff. It's so damn cool. Definitely wrong about that though. Do it. I am not. Why must I think anymore? Oh, that's so awesome. Okay. I am going to go do some other stuff quickly. I will be back, God willingly, and if we live.